Hello, welcome back to my second math video. Today we're going to be talking about angle theorems. All the types of angles you'll need to know. Now I wonder, you've probably heard different angles. Maybe something called vertical angles. Maybe something called corresponding angles. And sometimes you may hear something called, maybe, if I can spell it right, alternate interior angles or alternate exterior angles. And you may think to yourself, well, what does that mean? I don't understand what an alternate interior or an alternate exterior angle could mean. Well, fret no more. I'm here to teach you all about it. So let's jump right into it. All right, here we are back again. We have our famous parallel lines cut by a transversal. It also might look like you're saying something's not equal to it, such as my knowledge is not equal to the same of a teacher's, but we're going to do it anyway. So here we have, I've labeled numbers 1, 2, 3, 4, 5, 6, 7, 8. I'm sure you can read numbers, but I was going to say it anyway. All these numbers, we can correlate to different types of angles. Now stick with me here. There's about 7 different types of angles we're going to talk about. Sounds like a lot, but I promise you, we're going to go through every single one through an explanation while working on an example. So I'm checking off 2 things at the same time. First of all, we're going to focus on these alternate interior angles. Now, alternate interior angles are exactly what they sound like. They're interior angles, meaning they're going to be in this general area, but they're alternate. Now think for a second. Something that's alternate, what could it mean? Well, in this case, it's meaning it's on the opposite sides of the transversal. So as an example, if I were to say a pair of alternate interior angles, a pair of those could be 4 and 5. Well, why? Because you see, well, it's cut by the transversal. They're both on the inside of the parallel lines, meaning they're both going to be, or together, they're going to be alternate interior angles. Moving on, let's go to the opposite. Let's look at some alternate exterior angles. Well, if you know now what alternate interior angles are, alternate exterior angles are also cut by the transversal, but they're on the outside of the parallel lines. So trust me, I think you have it by now. And a pair of alternate exterior angles could be 2 and 7. They're on opposite sides of the transversal, but they're both also on the outside of the parallel, so it's 2 and 7. Next, we're going to look at those corresponding angles. That word that sounds very interesting. Well, corresponding angles, as it may sound, meaning one is going to be on the outside of the parallel lines and the other is going to be on the inside, but they're both going to be on opposite sides of the transversal. For an example, we could choose 1 and 6, or we could choose 2 and 5. For this example, we're going to use 3 and 8 for those corresponding angles. Next up, we're going to look at some vertical angles. After taking a brief look at my notes so I make sure I get this right, vertical angles are angles that are opposite of each other. Now, it doesn't say opposite in there, so I'm just going to jump right in and tell you. An example of vertical angles would be 1 and 4. Or 2 and 3. Why, do you say? Well, they're going to be on the opposite side of the transversal, and they're also going to be on opposite sides of the parallel line, but they're going to be right near the parallel line. You're not going to switch, oh, it's here, no, it's here. No, 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 that's a corresponding angle. But here, 1 and 4 are both, or together, they form vertical angles. Here's the thing. All these angles right here are congruent to each other. So, if I have alternate interior angles 4 and 5, those are going to be congruent to each other because they have the same angles. Alternate exteriors the same way. 2 and 7, they have the same angle. Corresponding 3 and 8, they have the same angle, and 1 and 4 have the same angle. Now I would explain to you why, but that goes into a different video. So maybe another time we'll do that. But didn't I say there were 7? You're right, I did. In fact, you might be wondering, I wish I didn't have 7, but we do. Here we are. We're going to keep going. We have same side interior angles. Well, by this point, I think you probably know what this means. Interior, we've learned, is on the inside of the parallel lines. Same side interior, however, is not going to be alternate, because if you know the dictionary, same and alternate are not the same thing. Aha, but I love puns. I just realized I completely had to go back because for same side interior, I realized I kept saying, oh, they're on the opposite side of the transversal. Well, that's not right because as we've learned, same and alternate are not the same thing. So I'm going to go back. 4 and 6 are same side interior angles because they're on the same side of the transversal. Same thing with same side exterior. They're going to be on the same side of the transversal, but they're going to be on the, for interior, they're going to be on the inside of the parallel lines, and for exterior, they're going to be on the outside of the parallel lines. So for example, same side exterior, we're going to use 1 and 7. That looks like a 7. It's supposed to be a 1, I promise. And we've got one more. Bear with me. We've got one more. And this is called a linear pair. Well, let's see. What's a linear pair? Well, if you know linear, if you take the AR off, it says line. Well, a line equals 180 degrees in this fact, and if you're thinking that, you're on the exact right track. A linear pair is going to be something that's cut by a transversal, but they form a 180 degree line. For example, 1 and 2 would be a linear pair because they're on opposite sides of the transversal, but together, the measure of angle 1, that's not a C, plus the measure of angle 2 will equal 180 degrees. Same thing can be said for 5 and 6, or 3 and 4, or 7 and 8, but we're going to use 1 and 2 for this example. Now, as I said, these are congruent. Are these congruent? No, or else I would have included it in that. These 3 right here are supplementary, and if you know what supplementary is, I'm hoping you do. Supplementary angles will equal 180 degrees. So let's take a minute. Okay, these 3 parts right here all equal supplementary angles. The easiest to see it at is the linear pair, since it does form a linear line. But I promise you, same side interior and same side exterior also do form supplementary angles. Why? The laws of math. I didn't come up with the laws of math. Someone else did. Maybe it was Aristotle. Kind of forgot. We're going to keep going. I just showed you the 7 different types of angle theorems. Now, could there be more? There probably are. Have I learned about them? Nope. So we're going to wrap this up really quick. As I said, you've learned 7 different types of angle theorems. You've learned that 4 of them are congruent. You've learned that 3 of them are supplementary. If you see this shape right here, you're most likely going to be asked one of these 7 questions, maybe all 7 at the same time. I don't know your tests. Anyway, so thank you for joining me on angle theorems. I hope you've enjoyed, and maybe, just maybe, I'll be able to speak this part without messing up. I hope you have a great night, day, afternoon. I don't know what time of day it is. Have a great life.